Hello friends, hope you are doing well. This is my third video on how to become a successful software developer in 4 weeks of time. This specific recording is for giving a high level overview on list of languages, frameworks and tools used by software developer in their career. To get to the list of programming languages, frameworks, and tools, let's backstep a bit and try to understand how do these need of programming languages, frameworks, and tools comes in. So first we start with software development lifecycle in an agile model. And as part of the project requirements, what are the different types of applications software developer will need to develop? And based on different specialities required. There are special skills required, obviously, for developing these types of applications. That's where even software developer is being divided into number of types. So we'll discuss what are those types of software developers, and at the last, based on all these, we'll easily get to the list of programming languages, frameworks, and tools. So let's kick off. In an agile delivery model, development lifecycle model, um, customer or the product owner who sets up the priority of 2 to 4 weeks of requirements, which is being set it up as a sprint. Everyone in the project team works to deliver for this specified 2 to 4 weeks of requirement set it up in the sprint and deliver the product which would be the improved version of the previous product which is there in the production, and so end users will be having access to improved product features. That's how Agile continuously works. This is also called an incremental delivery model. Every increment, basically, at the end of every sprint, customers is going to have incremental version of a product, which is also an improved version of a product with more features in the actual project or a product. So here, the developer is the one who is going to get the requirements from the analysis phase and solution architecture from the design phase and works with other developers. Obviously, in a project team, developer is not himself. He will be having his peers who will be helping him developing other requirements. He might be developing some of the project requirements. The other developers might be developing the other project requirements as well. Sometimes, these guys, the developers, will be co-located, and sometimes they are working in they probably could be working in a hybrid model where some developers working on site, some developers working in different cities or even sometimes different countries. Even for sake, like, sometimes the developers might need to work along with other developers as well in the other organizations. So it all to the needs of project requirements. As per the needs of the project requirements, developers will need to develop different types of applications. These are all the types of applications developer will develop for the needs of end users or customers or other organizations or systems. I have detailed slides on each application type, but for this web application is one of the application type. Say my requirement from the customer is that developer, you go and develop the application for my end users who access the application just from the web browser over the internet or intranet. That's where developer will get to know, okay, I need to develop an application for my project, for customer project, where I need to develop an application so that these guys can access it from the browser. So I will definitely go into web application type. That's where the requirement is. If the requirement from the end user or the customer is that you don't need to develop anything for my end users through web browser, there are a lot of other systems where you just need to expose the data, expose the information. They will just call us asking for specific detail, and you just respond back via certain protocols. say XML or some just like a plain text. I say a code, I want a customer details with the customer ID 10. They will just pass customer with the ID 10 in a plain text. You just return the customer details. It will not have any user interface or anything of such. For such requirements, I would just go ahead and develop web services or application programming interfaces or microservices. There are requirements where I don't want, as a customer, my end users will not be available over the internet or intranet. They should be able to access my requirements via just like their laptops or their devices. That is where standalone applications would come in. Basically here end users will just install the application in their machine and probably they'll just access it. That's the requirement where the developer will implement standalone application. There are sometimes requirements in the project says every regular interval, say for every day or for every week or every fortnight at specific point of time, have a go and check whether things are going fine or not, and generate a report and see how the things are going at to my customers or administrators in the business. Have a look at these scheduled reports generated by the batch jobs and then make some decisions on how my product is working well in the production. Reports are the ones which are going to helpful for the customers. Again, the product owner or his partners going to look at these reports, and they're going to look at the reports and find out whether how their business is performing, which area where in which area the most of the customers are accessing their product. Say for all these types of applications, say if you look at a shopping cart website, these end users can access the shopping cart website using the web browser like Chrome or Edge or any of these browsers. That's where the web application is suits to the needs of the project requirements. And as a organization, say I'm starting up a business, I wanted to set up a restaurant, and I would like to know where the customers' demand is more. Generally, just an example purposes here, Google.com. Google have most of the data. That's where they are pretty much their profits are mostly on the advertisements. So as an end user, I use Google.com website and look for nearby restaurants. When I get all the list of restaurants at the same time, Google captures the data as well and store it somewhere in their data centers. I'm the organization. I'm setting up one of my startup. So now I'm representing an organization. I would like to interact with Google and get me where the most of the demand is for customers who wanted to have a restaurant. It's basically where the customers, nearby, wherever the customers search for nearby restaurants. And that's the data I needed from Google. So I would want that information from Google via B2B. That's where Google will expose some of the microservices or web services or application programming interfaces. That's an example of web services. Um, and then standalone applications. This is where one of the example could be as part of my project. Say, all my end users they would like to understand their monthly payments based on their principal amount, mortgage interest, and length of the mortgage duration. In this specific requirement, I don't need to have a web application. I don't need to have a web service. I just need a small Excel or Access based application, MS Access application, which can be straight away installed in user's mission. So if that is how the requirement is, we'd go with standalone. Developer will go ahead and implement standalone application. And again, batch jobs and reports, as I said, depends on the project requirements. Every day or every fortnightly or weekly, at certain point of time, a program has to have a quick look at inventory, whatever the inventory is coming, and for a shopping cart website to cater to. Based on the inventory coming in, you just import that file at the specific point of time, and it will upload all the inventory to shopping cart website, so all my end users can see new inventory, whatever I have been uploaded as part of my batch job. And the reports, again, that's one of the project requirement. Depends on project requirement, you might set up that batch job. Yeah, you might develop as a developer, you might develop the batch job. The reports are the ones which are extremely helpful for the customers or even the end users on, say, in a shopping cart website, what I have spent for for the last month. That's one of the reports, right? So that could be used by end users or the customers as well. Sometimes in which area most of my traffic, most of the customers are being presented in. Most of the customers are either accessing my website from US or UK or Australia. All these reports are going to be pretty much useful for the customers so that they can focus more or improve improve their shopping cart website to the suitability of other regions as well. So those are the different application types. As I said, every application type is different here, and again, every application type is developed based for the needs of the project. If the requirement says developer that he has to develop certain features, based on the features or requirements, he will develop these types of applications. End users and customers are the ones generally access all these applications except web services slash API or microservices. They might indirectly access it, but directly they access only web applications or standalone applications or reports. So even bad jobs, they will not have any relationship with. Organizations, other systems, they interact with applications using web services. Bad jobs runs behind the scenes. As I said, one of the example of the inventory system, where you'll get a lot of inventory, and every day or every fortnightly, every week, you get an inventory. Your inventory is loaded to your shopping cart website as part of the bad job. There is no interaction with customers over here. But once the inventory is uploaded to the shopping cart, that's where end users can see your products. Let's jump into in detail of what each of these application type is. As you see from here, the end users or customers access your web application through their web browser. They don't need to install anything. They just need to have an internet connection, or if they're accessing this web application from their organization network, it's an internal facing. So, say if a web application based on the project needs to be accessible by everyone, including public, that needs to be accessible via internet. That is called public-facing application. And if it needs to be accessible only through the intranet, organization intranet, that's we call it as internal applications. So here, as I said, user doesn't need to install this application in their missions. It just need to be it will be just accessible from their web browser. Because of this nature, it is also called thin client applications, and sometimes they are called enterprise web-based applications as well, as they are applicable sometimes to the enterprise needs. Enterprise is a big business, right? So it is applicable like Amazon and eBay to the needs of enterprises. So we call it as enterprise web-based applications as well. The examples are Google, Facebook, Amazon. Those are all web applications. As you see from the web application, internally, they're all organized in this structure. Basically, it will have a front end, which is a user interface. When you access the web application, what you can only see is the front face of it. If you access google.com or Facebook or Amazon, what you are seeing is only the user interface part of it, where you are typing your inputs and submitting something, submitting the order, or just clicking on submit button or clicking on next and wizard kind of experience. Once you click on next, what happens is happens in the behind the scenes. It is not visible to the end users. It is all done as part of the web application request. User requests something through the user interface. Once user performs some action, say submitting an order or clicking on a button, that's where user interface interacts with backend. This is where it could be API or web service or microservices, get some data from the database and serve them. Say I want all the new brands coming in for the new hairstyles also. So here, customer access clicking on a button for all looking at all the new brands coming in his required area. Then the user interface gets the data from the database and then send it back to the end user. That's how end user at the end of the time he can see all the new brands, whatever the request he wants it from the shopping cart website. I say this is how web application looks like. Even as you see, sometimes your shopping cart website say it might need to have integration with other systems as well, like courier organizations or PayPal or anything of such. At the end of the day, end user only see the front end, which is user interface. All the operation happens in the back end, which is through API or microservice or web service. Either it interacts with database or even integrate with other systems like courier companies or payment integrations. It will serve to the needs of the end users. That's how web application works. The second type of applications, which is partly as part of the web application here, is web services or APIs or microservices. These types of applications will not have any front end. As you see from here, there is no front end. Whereas in the web application, you can see there is a front end where users will interact with through their browser. Web services are nothing but a piece of software which are available or accessible over the internet. The end users of these web services are other organizations. Basically, end users will not access the web services directly. These are other organization systems, like, say, an example, like, as I said, a restaurant owner who would like to know where and all the other places for giving him best business opportunity. Searching, interact with Google API and find out where and all the places customers are looking for restaurants. Customers are searching for nearby restaurants. That's a API, that's a web service he's going to call it, which Google is the one who is going to develop this part, web service. As an organization, restaurant owners, they call the API, they get the results, these are in all the locations where there is a more demand in. So organization, it benefits the organizations to build their business, to improve their business. But if you look at the structure, the web service at the end, it will still integrate with other systems, or even it might just look for its own database. Again, the advantage here, as you see, user don't need to install anything. They'll just need to call the API or web service through certain pattern, which we'll discuss in the next videos. But this is how it will happen. It is used to communicate between two systems. Sometimes even this person, this enterprise or this organization might have a front end which will just call this backend. As you see in the web application, everything is packed together as one web application with user interface, backend, API, and everything together. But whereas here in the web services part, uh, the Google kind of organization or the provider of the API will be having only the backend. The front end probably will be developed by other organizations. And then they invoke this API call. They get the data and they will that will serve the needs of that specific organization. So here you go for the web service. So that's it for pretty much like web services. Even the other example of it, shopping cart website or anything of such, it can integrate with other systems like here. Even this one we can call it as this integration Also, an example of web service or API or microservice. One backend system call other backend system. Even these could be the microservices or APIs or web services. The next type of application is standalone application. As the name says, it's a standalone. It doesn't need to interact with the other systems or available over the internet. These specific applications needs to be installed in their end users machines, and user need to basically install it, otherwise they will not be able to access these standalone applications. They are also called thick client applications because they need to install these applications in their machines. Example, MS Access and Excel applications. Some applications, these the client or standalone applications as well, they might have connection to the database or something in the network file system. Mostly these are internal to the organization. These are not public facing, like you can't develop some standalone application for anyone in the public sometimes. And most of the times these are being developed for the internal customers, internal organization wide users. As you see, the network file system, if the application has integration, standalone application has integration with network file system, that is only accessible for organization-wide customers, organization-wide employees. Even it has connection with database. Again, it's only available to certain set of people who have installed the application in their local machine. The next upset of applications are batch job applications. If a requirement says, as I said, I want a specific batch job process to have a look at the new inventory every week and upload that inventory to the shopping cart website. If that's a kind of requirement, it is developer has to develop the batch jobs. Users don't interact with the batch jobs, and they are configured to run at specific point of time on regular basis. These are also called cron jobs. Yeah. So as you see, it's pretty much the same structure as web APIs, but this is not being called by anyone. They will call themselves on irregular intervals. Have a look at the inventory and upload the shopping cart inventory to the database. So web application, the shopping cart web application can show this new inventory to the end users. Even as part of the batch job, it can integrate with other systems as well as required. Say if it has to check the payment status of a specific customer, it has to go to the payment gateway and check it properly. Yeah. So that's a type of application, batch job. Reports are other types of applications. Say most of the times what happens, if, for example, I'm acting shopping cart website quite frequently, and by the end of the month I might have spent few $100 where I have spent my money in, like an invoice which might come up for every order, but at the end of the month I would like to know how much money I have spent. That would be a type of report which for end users, probably project requirement says for the end users, they might come in and give the start and end date and show all the transactions they have done between those start and end dates, and even they can export that result into Excel or PDF format. That's we call it as reports, right? So even customers might need some intelligent reports from from which area most of the customers are accessing their website and which area there is a low usage of their shopping cart website, so they can focus more on there to improve, to attract the customers or end users, sorry, end users. So that's where reports are very much important for every the project. Most of the times project requirements will have couple of reports as well. So generally these reports, or sometimes call it as analytics as well, derived from multiple sources, not just from one database, or it might need to interact from multiple data sources, databases and data sources to get you the report. End users will access the reports via just use this browser, and sometimes a reporting application as well. You don't need to install application the specific report to your mission. That's one of the beauty of the reports. So now, so far we have discussed different types of web applications. Every web application requires developers to do certain special job, right? So if, as you see, there are three types of software developers to start with: front-end developer, back-end developer, and full-stack developer. Full-stack developer can do all the work done by front-end developer and back-end developer. It's pretty much like combination of both front-end developer and back-end developer. That's where the attractive salaries comes in to full-stack developers. At the same time, the more work will be falling on them as a full-stack developer. Front-end developer will look at only the front-end user interface aspects of a project or a solution. In your project, there is a requirement to build a shopping cart website, say, a specific screen, say checkout screen, or browsing or navigating through all the items in the shopping cart website. That's where the user interface part of it is being taken care by front-end developer. Front-end developer will not take any responsibility of what happens when the user clicks on a button and happens in the background. Interaction with the database or integration with a web service or integration with courier companies or payment integrations, that is all done by a backend developer. As you see this block of code, backend developer is the one who develops the backend APIs, web services, microservices. Backend developers can generate reports, analytics. Backend developer develops batch jobs, and even he will be developing the integration with other organizations, and even build a lot of queries, constructs a lot of development on database as well. Though it looks small from the front end development point of view, it involves a lot. Front end developer has to understand the customer journey, and also he has to beautify the screens, beautify the navigation, and also make the website more accessible to the end users in a nice and easier manner. The end-to-end navigation looks to end-to-end navigation, the overall menus, and how the screen navigations come from one screen to the other. It is all taken care by the front-end developer, while back-end developer takes care of actual business transactions. Front-end developer work is mainly involved in attracting the customer, using your website in a more user-friendly manner. Full stack developer has both the skills of user interface development, front-end development, and back-end development, reports, batch jobs. He can do everything. That's a beauty of being a full stack developer. Coming to the programming languages, frameworks, and tools, this is where the conclusion of this recording. As you see, front-end developer will do the user interface. There are skills, programming languages, frameworks, and tools attached to it. Every block, what we have over here, there are programming languages supports, and the frameworks and tools support these blocks, what we have over here. Let's look into those blocks and map what and all the programming languages support these blocks. User interface or front end, which is basically a front end developer job. HTML, CSS, and JavaScript, these are the main programming languages front end developer has to learn. As a backend developer, these are all the blocks or the skills required. And backend developer needs Java and C Sharp as the base Java, either Java or C Sharp. You expertise in either Java or C Sharp, you can develop the APIs, web services, and microservices. And also you can develop bad jobs. You can develop integration with other organizations like courier companies and payment gateways, as I said. With Java or C Sharp languages, you can develop these three: backend APIs, bad jobs, and integration with other organizations. For reports, Java and C Sharp languages as well support generating reports, but nowadays it is mostly moved to SSRS reports or Power BI. You need to learn Power BI or SSRS reports to develop the reporting aspects of the project requirements. For developing anything in the database, you need to learn SQL, which is structured query language. Mostly a Java developer, or mostly like these backend developers, whoever learned on Java or C Sharp already might have learned SQL as part of learning Java or C Sharp itself. So these are the typical programming languages which I'm going to cover in my course. Let's jump into programming languages, frameworks, and tools. What happens is learning a programming is language is not a big job. You can easily learn it. But when it comes to development, there will be a lot of complex requirements. And even sometimes there are a lot of common requirements which are same for any web application development. If you consider either shopping cart website or Facebook, Google, Amazon, eBay, they're all web applications, right? So when you are developing these web applications, there are common requirements which are being implemented as frameworks. You don't need to reinvent the wheel. The frameworks are there to help maintain the standard structure for the application. When you know the framework, which I'm going to have the list of frameworks and tools and all these in the next slides, when you learn the framework tagged against each of these programming languages, you don't need to know the low level details of each and every programming. The frameworks covered the low level aspects of these programming languages. So by learning the framework, it's quite easy to do the development work. At the same time, frameworks helps us to maintain the standard structure for the application. I'll just navigate to web application screen and I'll tell you why the frameworks are so important. Say for example, this is a web application structure. Users access the web application through browser. We have user interface, we have backend API, we have databases and integration with other applications. This is how any web application looks like. Google, Facebook, Amazon, or anything. If everyone starts looking at their own way of building the common aspects of it, from browser interaction to the user interface, and then the way how user interface developed, the way backend is developed, the way database is developed, if everyone looks at implementing their own way, it's so hard for developers to switch from to maintain these applications. Imagine a developer works in Google, tomorrow jump into Facebook, and he has to learn entirely new thing altogether. Developer worked on Facebook, moved to Amazon, just an example, right? They have to learn everything new because everyone developed their own custom way of developing these web applications. That's where frameworks came in. One way they simplified the development of these web applications. Instead of everyone build the web application on their own, say this is the standard structure of web application. Instead of everyone comes up and say mix up their front end code, back end code into one layer, and even database code into one layer, right? The frameworks are going to make sure you develop the front end only over here, you develop the back end only in this layer, you develop the database only in this layer. Frameworks enforce the developers to do the development in a standard structure. That's the beauty of frameworks. And so tomorrow, if a new developer comes in, it's quite easy to train them. And at the same time, if there are two, three developers and one developer writes a code, other developer can easily come in and understand the code. So it's a standard structure which is quite important for any developer. As a good developer, you need to understand what's the standard structure to be developed, which is being enforced by frameworks. So the moment you learn a framework for these applications, for these programming languages, you will be following that structure. That means you are friendly to the other developers as well. So that's where frameworks are going to be helpful to maintain the standard structure for the applications. And as frameworks is a reusable piece of software, basically which is created as per the best practices and standards in the industry. You don't need to learn all the best practices, all the performance wise, which one is the best way to implement the code. You just need to use that specific framework which is already been good in the industry, and so you are inheriting all the good nature of this framework as well in your application, in your developed application. As a software developer, it's quite important for you to pick the right framework. You need to work with your technical lead and software and solution architect and pick the good framework so that you can develop your application in a nice and standard manner. Say if a framework is like pillar of the house or the structure of the house. If the structure is good, you don't need to touch that house for a lot of maintenance reasons again and again. It's very much same reason. If the framework is good, your product, your application will be more maintainable. You will not be Your customer will be more happier because he don't need to spend a lot of money on maintenance. Instead, he will spend money on improving the product or adding more features to the product. So that's where frameworks help the application developers speeding up the application development works. Obviously, they don't need to develop all the small bits and pieces. They just need to include the framework in their application, and so it will help them speeding up the development work. So it's kind of no need to reinvent the wheel. The framework is already best suitable and developed as per the best practices and standards in the industry. And also it reduces the number of lines of code in the application. The moment you have a lot of code in your application, obviously you need a lot of developers, right? Yeah. So if you include the good frameworks, it will reduce the lines of code and it will reduce the maintenance. It will reduce the number of developers required for developing the project requirements. Some of the examples of frameworks are Spring, Hibernate, logging, Log4j, Logback. For reading files, there are Apache Commons and stuff. I'll be having more videos. I'll be having videos on describing each framework, each tool, which we are going to discuss in the next slides in the new videos. I'll publish more videos on them. But just to benefit of what the framework is, Spring is one of the Java framework which is going to make sure that the developers have developed the applications as per the standard structure. Spring will ensure all the developers maintain separate code block for front end, separate code block for back end, separate code block for integrations and all the aspects of it. It helps a lot and it is a quite famous framework. Learning Spring Framework, as I said, I'll be publishing more videos on this in the next sessions. Learning Spring Framework will make you developing a web application so fast, so quickly, at the same time following the best practices and standards in the industry. Hibernate is one of the framework. When your application is integrating with database, using this framework allows you to make sure your application is best performance in terms of when integrating with the database. Logging and Log4j and all these frameworks for every application. Mostly, the project requirement says a customer say an example shopping cart website. When a customer try to log in and browse through number of products, Make sure what the customer is doing, writing to certain, save it, save what customer is doing it when he's browsing through shopping cart application. That's where, if your customer is not happy and left the shopping cart website, later these are the statistics, these are the places where you save their customer journey, user journey. You can say, okay, probably customer might have left your website being unhappy, he couldn't find their product what they're looking for in your shopping cart website. So instead of you writing as a developer, creating a file and then logging all these things as a separate lines of code, using this logging framework allows you, just with one or two lines of code, you can say what customer is doing in the specific customer journey. So that's like those are some of the examples of frameworks. As I said, it's quite, once we have more videos, one new video for each framework, each tool, you will understand these things better. But at the high level, frameworks are going to help the developers in developing the applications as per the best practices and standards in the industry, and making sure the structure of the application is quite neat and maintainable. So new developer comes in, they can easily maintain the application. The tools, on the other way, are basically, as you see, it's pretty much same for any industry. If you don't have right tool, it's going to take enormous time to complete your job. One of the best thing in a software development is that you have a tool called integrated development environment. As the name says, it's integrated into your development environment. Basically, when you start your work, all the tools required for your development are being integrated to one single tool, which is called IDE, Integrated Development Environment. As a developer, you don't need to switch between so many screens, so many tools, and do your work. You just need to install one tool which will have all the plugins, all the installations, all the extensions. You can just focus on your work in that specific IDE. That's the beauty of tool and the IDE, and it improves the productivity of the developers. Obviously, instead of you focus on, imagine if you are developing application in one screen, you don't have two three screens, one screen. You have to keep switching back and forth to the coding screen. It's going to be quite difficult, and it reduces the productivity. So that's where, everyone as a developer need to learn IDE. I'll be having a new video on how to use IDE as well. Once you learn how to use IDE, it's going to be quite easy, quite quick for developing the project requirements. These tools will assist also setting up and enforcing best coding practices in the team. So, say for example, I'll just switch to one of the tool, Eclipse. This is how Eclipse looks like. Imagine if you're writing a code in Notepad or something like that. This is how you write the code, right? Say code block one, or you enter this code block one, and so you close it, you close the braces. This is an IDE, how it looks like. Basically, in IDE, there are this is a tool basically for developing Java applications. I have created one file already, sample.java. If you look at it, the intention and all these, like, the number of lines, gaps, and it shows the line number, and it maintains the structure of the file so neatly. Um, if I create one more file, say if I want to create new Java class, for example, see this one, the use of default packages discover discourage, showing some warning symbol. And also it's allowing me to generate the comments, and it's allowing me to pick some options which will be automatically generated as part of this specific interaction. So this is my class where the comments are generated automatically, and even the methods are generated automatically, right? And also, if I'm doing something wrong, it will give you an error message as well at the top, just beside that line, that something is wrong over here. So these are some of the examples of IDE where if you're typing in Notepad, see there is no error or warning or any message. You can type whatever you like. But whereas when you use IDE, you can see some in the markers. So over here, if you look at it, there are two errors in your code. This one cannot be resolved. So if I want to create a string, something like that, string variable, so now, if you look at it, the error is resolved. Now it is giving something else. The value of the local variable var is not used. What it is saying is it is not used anywhere. If you don't use anywhere, it will obviously give that message. So here now it is a string. I'm trying to assign to integer, so it's giving an error as well. So I try to give a as a normal string. The error is gone. So this is one of the advantage of tools where it will give alerts, warnings, and errors. It will show on the same screen as you are typing the code, as you are developing the applications, and also it has various extensions in the help. If you look at it, Eclipse Marketplace. This is just an example of one of the tool, Eclipse. You can go to Eclipse Marketplace and you can install the tools what is required for your project as well. See, these are all the tools. Say one of the plugin called check style is that it will, yeah, check style. This is basically to once you install this plugin, it will check the code quality or beauty of your code, and it will auto adjust all the development you have done so far. And also, when you are typing the new code, it will auto adjust as well, or it will give alerts and warnings that you are not following the best practices. All the best practices are being configured in the check style specification. Those are the key benefits of using the tools when you are doing the development. Back in old days, people used to do the development in Notepad and all, but once we have these tools comes in, it became so easy to become a software developer. As I said, it's all about the concepts you need to learn, and then once you learn the concepts, it's all well and good. As the next slide, as you see, I'm listing down all the frameworks and tools generally use it on day-to-day basis, and then go to a specific frameworks or go to a specific languages, and then we'll end up this one. The day-to-day activities as a software developer, as we discussed, you'll be pretty much working in agile sprint delivery model, and various tools you'll be using in general are most of the times organizations are now using MS Outlook for email communication. You will need to communicate with a lot of developers in other teams or your team. You'll be using obviously Outlook or Gmail for the conversation. Gmail here is Gmail for business if organization is using it, and then MS Teams or Zoom or Hangouts for regular conversations. If you're working, you don't need to have email communication where you think you can just directly chat with someone from your organization and get the responses. You can do it using these tools. So basically, you can organize the meetings and things as well using Zoom and Hangouts as required. Generally, the daily stand-ups are being organized obviously using these tools for every day. And the next set of tools are quite important from here on. And I'm going to publish new videos on each tool, which I'm going to mention from here on. Jira. Jira is one of the tracking system. Basically, when you are working in a project, everyone in the project working on something, and all these items team is working on are tracked in Jira. Jira is a Atlassian product. Again, it's a paid product. It's a licensed one. Generally, organizations configure Jira, and you'll be adding as a developer role to the Jira, and you'll be assigned to certain tasks, and even you can create your own tasks as well in Jira, and you can start using it. Yeah, I'll be having a separate video, as I said, on Jira. But at the, overall, this is the tracking system, one of the tracking system used by many organizations nowadays to track the project development works. The next one is Confluence or Objective. As you know, as we discussed in the SDLC development lifecycle, we have analysis, design, and all these phases. In every phase, um, either it's solution architect, business analyst, or you as a developer or a tech lead, they deliver certain documents. It's not just the coding. Basically, say a software solution architecture or business requirements document, they got to be stored somewhere and shared with the team. So Confluence and Objective are the places generally organizations or the project teams share uses to store the documents, or to create the documents for knowledge sharing purposes. MS Teams is also one way, you can just share the document using MS Teams to your colleague. Very much same. Confluence is mainly, the project related documents like, budgeting, planning documents, which will be done by project manager, business requirements, solution architecture. Those documents will be stored in Confluence. Or Objective is one of the other place. Both are licensed products. While these are like more of like communication purposes, all these tools are mainly for communication purposes, working with your team in a more collaborative manner. From here on, most the tools are more of like coding tasks in nature. When you are doing the development work, you do certain coding. Say, for example, you developed 100 lines of code, and your other developer, your basically your team in your team, you have 5 developers. All the 5 developers developed around 500 lines of code. At the end of the day, they have to make sure they commit this code and store this code in a centralized repository, which is called GitHub or Bitbucket. GitHub is a free version. Recently, Microsoft has acquired this. Earlier it used to be, or even earlier it used to be open source. Now it is being acquired by Microsoft. Bitbucket is Atlassian product. Jira, Confluence, and Bitbucket, all three are Atlassian products. Bitbucket is licensed, same like Jira and Confluence. So these are the places developers will go and store their source coding. The main advantage of storing the application source coding over here is that, say what happens, you developed so much of free project requirements, you developed 1,000 lines of code, and your system crashed, and you don't have backup or anything of such. Imagine what happens if for three developers the same thing happened. It is a major risk to the project, right? So that's where we have these things as source code repositories. We call these two as source code repository tools, GitHub and Bitbucket. Git is a client tool. Every developer installs Git as a client, Git as a client, Git Bash as a client tool. And then once they complete the development work, they constantly, regularly, as a good developer, they push the application source code to either GitHub or Bitbucket as decided by your tech lead or as an organization. Generally, organization have either Bitbucket or GitHub. Generally, so if you're working for the organization as a developer, at the end of the day, you have to commit or push or store your source code to GitHub or Bitbucket. So that's the advantage of source code repositories, and that's the advantage of Git. Using Git commands, basically once you install as a developer Git, Git has commands to store the source code into these systems. Git supports both GitHub and Bitbucket, so doesn't matter your organization uses GitHub or Bitbucket. You just need to install Git and learn some commands. Using those commands, you can push your source code to GitHub or Bitbucket. I'll have a separate video on Git alone later. And then command line is one of the key thing as well. In the day-to-day nature, you might need to connect to various other servers and see how the application is behaving, or you might be assigned a develop. You might a tester might assign you a defect. You might need to go and look at the logs in the test server. That's where you will be required to have these PowerShell or Linux and need to learn these PowerShell or Linux commands, which will be executed through command line tool. Putty is one of the software where you need to connect, where there is a need of connecting to the server. That's the time you need Putty software. Again, when the testing is happening or even end users complaints to the operations that something is not working well, you need to connect to those testing servers or production servers and go to certain location using the commands, PowerShell commands or Linux commands. You need to use it and go to certain locations and use those Linux commands again to open the file and look at the log file. But for connecting to the server, you will definitely need a tool called Putty. SFTG is something where you need to transfer some files to the servers. Say for an example, in a shopping cart website kind of example, you got a new inventory comes in, you got to push that new inventory file to your server. Then your code will look at that file and process and make sure the new inventory is available to the end users. Right. So here the use case is basically the main purpose of SFTG is that you need wherever you need to transfer some files, either it's Excel file, Notepad, or any kind of file, any data from one system to the other server or any system, then you would use SFTG as a tool. So these are the day to day you might use these tools. I would add more videos. I would add specific videos for some of the important tools like Git, the source code repository, and some of the Linux commands and Jira and Confluence. But this is the overall view, and this is the purpose of having these tools. For front-end frameworks and tools, for the front-end, HTML, CSS, and JavaScript, these are the frameworks and tools. So the frameworks for front-end are Angular, React, Bootstrap, React Native, and Ionic. Basically, all these frameworks, the one single purpose is that it makes sure you write less code. It makes sure your application looks beautiful. It makes sure you can have your application works in all the browsers and all the devices, irrespective of screen resolution. Your application works across. That's a main function, main purpose of using these frameworks. Depends on which framework you learn, you will be expertise in that specific framework. Angular, React, React Native, Bootstrap, Ionic, all of them, at the end of the day, as I said, their goal is simple to make sure you develop the applications with less coding and at the same time having a better user interface. Works with all the browsers and all the devices. They are built on top of HTML, CSS, and JavaScript. To start with, Node is one of the framework where if someone need a tool or a specific function in the front end application, there are a lot of packages available in Node. We just need to install the package and just use it. That's the purpose of having Node. Angular has its own framework where it has its own component. Instead of you develop using HTML, CSS, and JavaScript, Angular have its own tags. If you use Angular tags, the application will be more responsive. You don't need to worry a lot about responsiveness of your application. React is also similar, but they just follow the different principles. Angular comes everything with one big package, whereas React is pretty much like very lightweight. If you need more features, you need to install more plugins later. So that's where the size of the application will be lot less when you have React. Basically, if the application is quite simple and you don't need a lot of installations, lot of plugins and things, your application size will be a lot less in React framework. But whereas Angular, pretty much the size of the application, the framework, everything is included over here as one package. So the moment you include, that is all comes in as one size, one big size. Whether you use those features or not, Angular has those packages already installed in your application. Bootstrap is mainly for beautifying your screens. Basically, if you're having a lot of progress bars or the buttons and various input elements in the user interface, basically what user interface will have, like text box, check boxes, radio buttons, right buttons, and progress bars, navigations, widgets. All these things are being customized in Bootstrap framework. The moment you include Bootstrap framework, you can leverage those features in your application. So instead of you spend a lot of time developing CSS, developing style sheets for your application, you just need to import Bootstrap and use those frameworks, use those widgets or styles. React Native is one of the framework where if you have to develop the applications pretty much for the nativity, basically mobile native, say Android specific, iOS specific applications, and if your project needs to interact with the mobile devices or their actual mobile devices like camera, JS, and all these systems, that's where React Native framework is more helpful. Ionic is one of the beauty of the framework is that you develop once and you can deploy it anywhere. Basically, when you develop your application using Ionic, you can turn that into either Android application or iOS application, just using the same source code. You don't need to develop a lot of source code for developing Android and iOS applications. Imagine if you have to develop a separate application for Android, separate application for iOS, you would have to spend months and months of time. With Ionic framework, you develop the code either with Angular or React once, and then embedding Ionic framework will give you an opportunity to build the iOS and Android packages separately. Basically, at the time of building the package, it will convert your code into iOS or Android specific code or binaries, and it will make sure that the applications works efficiently in Android and iOS devices. That's the beauty of Ionic framework, and also it supports biometrics and a lot of new features which are coming up, facial recognition and kind of things. So that's one of the good framework to learn as well. Nowadays, all the modern applications, either applications front end, these front end applications, are either being developed using Angular or React, and then they are embedding Ionic over on top of it. The reason is that Angular and React, all of any application developed using Angular and React, they work perfectly well in all the browsers, all the modern browsers, and all the devices in a responsive manner. User won't feel anything of such that this application is not compatible with mobile or anything of such. They'll perfectly work. At the same time, Ionic, adding Ionic to it, is giving them an opportunity to build mobile application level packages as well. So pretty much Angular, React, and Ionic are the most standard frameworks for modern applications nowadays. People are not much using React Native, so I'll not be having any new video on this. This is just added for information knowledge purposes. Bootstrap, as I said, again, this can be embedded in Angular or any of the applications, so you can use those style sheets. You don't need to develop on your own. If you like some style sheet, you can straight apply that style sheet in your application. That's the advantage of Bootstrap. So that's it about the frameworks. And in terms of tools for these front-end frameworks and tools, front-end language like HTML, CSS, and JavaScript, Visual Studio Code is the open source. Using this Visual Studio Code, as I said in the previous slide, all the advantages of tools comes in as part of Visual Studio Code. You can develop HTML, CSS, JavaScript, or all these frameworks quite easily using Visual Studio Code. IntelliJ is not required. It is licensed, added just for knowledge purposes. IntelliJ supports user interface front end tools as well, but mostly people can go for Visual Studio Code or Eclipse. With Eclipse is also open source. Basically, open source means you don't need to pay anything. Visual Studio Code is also open source. You don't need to pay anything, but IntelliJ you got to pay for its licenses. So, modern days, everyone is going for Visual Studio Code. It has come up with a lot of extensions, plugins. So, if you are doing the development of application using Angular framework, there is an extension for Angular. You can install Angular or React. If you are doing, you can install React, and it will make the development so smooth and easier. That's it about HTML, CSS, and JavaScript, which are the user interface or front end parts of it and their frameworks and tools. Let's get into the backend development, which is Java is one of the most famous programming language for developing the backend components. Backend here means either it's APIs or batch jobs or integration with other organizations. These are some of the famous and most popular and modern applications are using these frameworks. The first four frameworks are being used by modern applications. The other or others like Struts and JSF are pretty much legacy frameworks. Not many companies actually modern application doesn't use this at all because they're already legacy and end of life as well. But sometimes what happens is if you are put into a project which is already developed using Struts and JSF, you might need to carry that legacy for a while. Keeping these things aside, let's concentrate on these four. As I said in our beginning presentations, as a developer, you would need to develop the application. Along with this, you got to test the application as well. The front-end frameworks here, they also support testing. Angular, React, and all of them, they have its own testing frameworks as well built in. But whereas over here, Spring Boot, or Hibernate, these are main frameworks for Java applications. If you learn these two frameworks, you can develop all these features, all these applications, either it's batch job or backend API or integration with other applications. You can develop it just learning these two frameworks. Spring or Spring Boot is mainly for web application purposes. Hibernate is a place where when you have to integrate with the database, this will make your job a lot and lot easier. You don't need to write a lot of structured query languages, a lot of scripts for interacting with database. Same with Java programming language, having the Hibernate included, you can integrate with database so easily and quickly and efficiently as well in terms of performance as well. Yeah. JUnit and Mockito, these two are unit testing frameworks. As I said, these two are for developing the applications. JUnit is mainly for unit testing your code, and Mockito is a place where if you have an integration with a third party system like courier company or payment system, it's so difficult to test it. Unless and until they are available, they give you all the details of their testing environments and testing accounts. It's so easy, so difficult to test it. That's where Mockito framework comes in. Mockito, as the name indicates, it mocks and behaves like a courier gateway or payment gateway. So when you test it, instead of you integrate directly with their system, we'll be talking to Mockito framework. Mockito will give all the possible scenarios back to the JUnit system or back to our unit testing. So that way we can test all the possible scenarios, whatever payment gateway or courier system or any third party system returns. Those are the use cases implemented in Mockito, and instead of talking to those framework, those integrated systems, our unit testing components, our testing will be done using Mockito. Make sure our application works properly. Forget about others, like payment and courier. As long as our application, your project as a developer, your code has been done and handling all the responses from payment gateway and courier systems is being handled, that is all good enough. There is another type of testing, which is integration testing, which as a developer you will need to do before handing over your code to a testing team. That's where you can actually test your code directly with your payment systems or third party or courier gateway companies. So those are the frameworks from Java point of view, development and testing frameworks. If you learn these frameworks, you are good to be going into a job for a software developer as a Java developer properly, I'd say. And you can do all these applications, back-end applications, batch jobs, and integrations. The list of tools you will be using as a Java developer or as a back-end developer here are Eclipse or IntelliJ. Eclipse is open source and IntelliJ is licensed. Once you install Eclipse, you can develop all these applications using these frameworks. They have Eclipse has plugins and extensions for the Spring and Hibernate, JUnit, and all this. So you can still do everything to everything in Eclipse. Of course, there are few organizations going for IntelliJ for some reason, where they have better look and feel and all. But Eclipse has pretty much all the functions required for developing Java applications, all these types of applications. Check style is one of the tool, as I said in the previous slides. Basically, it will make sure all the developers follow the same principles, same set of guidelines when they are developing the code. Say in the check style, you can say every line, every method or every line you should have, shouldn't have more than 300 characters. Every method shouldn't have more than 100 lines. Every file shouldn't have more than 200-300 lines of code. Those kind of policies you can establish in check style. And every time, even in check style, you can set up the code style as well, how the code should just format, like when what are the copyrights or auto generated comments and things you can configure in check style. So it saves a lot of time instead of developer to create those comments or copyright symbols for every file they created. Maven or Gradle, both are open source, free versions. Basically, when you develop Java code, you got to compile it. And once you compile, you have to get a binary of it as well. That's a binary file which will be installed in servers, and so end users can access the application. Though you develop any language, either it's Java or C Sharp or anything, there will be a compiler which will compile the code, right? And then it will generate a binary file. That's the file will be deployed in server, and so end users can access it. Maven and Gradle, these are the tools which will make this compilation and generating the binary part more easier. Using these tools will help developers forget about compiling it manually. Instead, run a Maven command which will clean, compile, and install on the binary objects, binary of the application. Jenkins is a continuous integration tool, basically. So Jenkins will one of the advantage of Jenkins is that, as I said, as a software developer, you'll be working with a lot of other developers, and when you are checking in your code at the same time, say probably other developer also might be committing or checking in, or like pushing the code to the source code repository, Git or GitHub and all these. That's a generic tool, right? Every developer has to know about this tool, GitHub and or Bitbucket. So there may be what happens is Jenkins is a continuous integration where it will look at all the commits and compile the code using Maven and install and even generate those installable libraries. One of the advantage of Jenkins is that every commit or every push you move to source code repository, Jenkins will validate anything wrong with your source code. It will have an integration with SonarQube. SonarQube is a quality system. It's basically validates and qualify your source code, whether you are doing the good development or not. In the sense, whether the number of lines per method, number of lines per class, whether unit test cases are created properly, whether source code, whatever you have written, is well covered with all the unit test cases. Everything is being tested in SonarQube. Jenkins most of the times actually have integration with SonarQube. Once it compiles the code with Maven, using Maven, and then generate the installable library, it will also go to SonarQube, pass all the source code to SonarQube, and ask SonarQube to qualify the code. So SonarQube qualify the code and generate a report saying how many unit test cases are failed, what's the number of issues in your source code written. All these things are being tracked under SonarQube. While Jenkins works as a continuous integration here. Continuous integration is being named here because number of developers works for project requirements and commit the code to Bitbucket, but Jenkins is the place where it continuously integrate with all the developers and generate the build, compile the code, and generate the installation artifact, and then pass to SonarQube and generate the reports. So that's why it is called continuous integration. It continuously integrates with all the code commits being done by the development team, list of developers. Nexus or JFrog, this is one of the important bit of it. JFrog is a licensed version. Nexus is a open source. Mostly people are going with Nexus now because it's a open source. If you have a simple application, go for a Nexus. If you have to develop a lot of artifacts, then JFrog is still a go. And also enterprises nowadays are going with JFrog because it has got better recovery. The reason, let's go for the purpose of what is Nexus and JFrog first, and then we'll understand why enterprises are going for JFrog. As I said, Jenkins continuously integrates all the code commits, all the code push to central repositories by developers, compile the code using Maven, and generate the binaries, which we call it as jar file, jar file in Java world. And it also checks with SonarQube any issues with SonarQube, and it can validate the gateway code quality. Basically, it can validate code quality with SonarQube, say whether everything is good. Then it can push that generated binary file to Nexus or JFrog. While I said here, GitHub or Bitbucket is a source code repository where all developers code is hosted over here. Jenkins will compile using Maven. It qualify the code using SonarQube, and then it push the generated binary file to Nexus. So this is the artifact. This is the binary artifact repository. While GitHub or Bitbucket is a source code repository, Nexus or JFrog are the binary repositories. Once your testing is done and tester says everything is good, and that's where that specific binary which is being released to the testing team and said tester is good, that binary will be deploying to production environment, so end users will use that. So here you go. Say what happens, once you deploy your binary from JFrog or Nexus to production environment, some event happened and you lost that repository. So the recovery is not there. You lost it. There is not enough backup. Though backup is possible over here, JFrog supports this lot efficiently, and also it's an enterprise wide thing. So because of licensing and stuff, there is an SLAs. If some issue is there, you can always reach out to JFrog team for support. That's one of the major difference between open source and paid thing. Open source, if you get some issues, you have the option is you have to post your query or issue over the blog. You don't know when you will get the response. Even you, there is a big community who is supporting open source like Nexus and things like that, but still, there is no guarantee of it. But whereas if you have a big enterprise, you need to respond to your customer needs quite quickly. JFrog kind of products where they have a customer support team. If you have issues, they will straight away get in and fix the issues based on the priority. But that's it. That's the main difference between open source versus paid. With paid, you will get some support, whereas with open source, you need to just rely on some open source blocks. SoapUI is the next tool, which is mainly for testing the web services. Say if you develop the web services, and you can test those web services using SoapUI. So that's it for Java frameworks and tools. And then C Sharp is the next programming language, which is again the same use cases can be done using C Sharp as well, but it has got a different frameworks, .NET Core or .NET Framework. Earlier, what happens is .NET Framework only works in Windows platform, but now Microsoft has released .NET Core as well. C Sharp is obviously Microsoft owned, Microsoft maintained language, and .NET Framework is as well. It's a Microsoft maintained. .NET Core now supports Linux platform as well. Say, for example, you develop an application using C Sharp, you can deploy your application at the end of the day in Linux as well if you use .NET Core framework. It is recently, I would say one or two, not very recent, 1 or 2 years back, it is being released. Earlier, we used to have only .NET framework, and so we need to constrain our production environment or testing environments or any of the development environments to Windows platform. But now, even with C Sharp language, if you go for .NET Core, you can deploy your code in Linux as well. The next one is NHibernate. It is very similar to Hibernate over here. NHibernate supports all the databases like SQL, MS SQL, and all these databases. There is one more framework called Entity Framework, which only supports Microsoft SQL database. Say if you are developing an application which has to interact with database, you use NHibernate if it is non-MS SQL. If it is MS SQL, you can use Entity Framework. Similar to Java, where you have JUnit and Mockito for unit testing, here also you have XUnit and Mock for unit testing your applications, which is developed using C Sharp programming language. Very similar to Java, where you have tools. Here also we have tools, which are effectively being managed by Microsoft here. Visual Studio Community is a version which is good enough for developing the applications using C Sharp programming language. And you have NuGet, which is very similar to Maven over here. Maven, like for building the application, you use Visual Studio and NuGet together. And Jenkins, SonarCube, Nexus, and ThopeUI are pretty much same as what I explained over here. developer working on your C Sharp language application, and Jenkins will continuously integrate that code using NuGet and Visual Studio. It compiles the application and it qualifies the code using SonarQube plugin. Basically, it sends the unit testing results and source code results, source code to SonarQube. SonarQube validates the source code and verifies number of unit test cases passed and send it back to Jenkins. Once everything is good, if the quality is good, then Jenkins will decide to move that DLL file. While Java is a jar file, C Sharp code mostly could be the DLL or the binary file will be sent to Nexus or JFrog, and that's it pretty much. And SOAP UI is there for validating the web services testing over here. The next one is SQL. SQL is a structured programming, structured query language, which are used to interact with database. So there are so many databases in the industry, but most famous ones are Oracle database and the MS SQL database. Oracle database, as the name says, it's Oracle is the owner of it. Oracle has developed that database, and MS SQL is a Microsoft SQL database. It's a Microsoft developed product, and either of it, if you learn SQL, structured query language, you can work with the databases. We have a couple of tools. Toad is a licensed product, not much required nowadays. Not many people are using it unless and until it is pretty much required some special reason. Most of the times, as a software developer, you just need SQL developer using which you can connect to the database, run SQL commands. You can either insert the database or insert the data in the database or get the results from the database, or even add new columns, or create new tables as well in the database using SQL programming language. The last but not least, we have reports. Reports, there is no special frameworks as such, but these are the key tools we have available for tools for developing SSRS reports. You can develop them using Visual Studio Community tool. You just need to install this tool, and you can install SSRS reports plugin or extension on top of it, and then you can develop the SSRS reports. Power BI Desktop is the tool for developing Power BI reports. Power BI reports are much more advanced than SSRS reports. I would say you can embed these Power BI reports anywhere you want. Of course, you can embed SSRS reports as well inside the web application or anywhere you like, but it supports more of like charts, bar charts, graphs, and various features of reports. It's much more advanced than SSRS because Power BI is pretty much developed for reporting purposes. Even SSRS supports charts, bars, and graphs, and all those features, but Power BI is the most advanced thing. It can connect to various data sources and stuff very similar to any reporting applications. So pretty much that's it, friends. I'm going to publish more videos on each and every tool and the framework what I have described in this video. Hope you enjoyed learning what are the list of languages, frameworks, and tools, and looking forward to watch you in the next video. Cheers. Thank you. Good luck.